artificial intelligence?
Louder.
Okay. Good afternoon, everyone. Today we are going to discuss a topic on artificial intelligence and its convergence with nanotechnology. So let's start. So before entering the convergence part, we have to first know about what is nanotechnology and what is artificial intelligence. So picking one at a time, first I'll explain what is nanotechnology. So nanotechnology basically deals with the manipulation, formation and control of matter at very nano scale, that is an atomic scale. At such atomic scale, these materials exhibit high surface to volume ratio and various properties that are distinct from their bulk counterparts. Coming to the artificial intelligence, it is nothing but a predictive technological tool. Artificial intelligence itself is nothing but just a predictive tool. It accumulates the data from various sources, takes out the abstract and then presents to us. Okay. So what does artificial intelligence do? It incorporates deep learning, reasoning, thinking, and the most important of all, the decision-making capacity. So I think we have now an idea about what is nanotechnology and what is artificial intelligence. Any questions, anyone?
Continue.
Next slide, please. Okay, so now we are entering the convergence part. That's why I have named it nano intelligence. That is the convergence of nanotechnology and artificial intelligence. So coming to the first part, here it is written a powerful synergy. The artificial intelligence along with nanotechnology gives us a synergistic approach towards the coming future generations. And what does artificial intelligence do? Artificial intelligence just provides us the data, gives us some basic understanding, while the main substrate, the main core understanding, the main materials are provided to us by nanotechnological advancements. Next slide, please. Okay, coming to the next slide, how AI powers neuroscience optimization. Now we'll look into how artificial intelligence, we have seen that artificial intelligence and nanotechnology are a synergistic approach. Now we're going to see how they are synergistically approaching towards each other. Okay, first we're going to take an example like, if I enter in a lab, as an example, if I enter in a lab, I have to encounter multiple error and trial methods so as to obtain my final desired outcome product. What happens is that it results in a loss of time, loss of expenditure as well, and loss of various other things. Also, we also know that the nanotechnological procedure is itself a very costly process. It's a very labor-saving process. So just to get rid of this, artificial intelligence in convergence with the nanotechnology replaces this hit and try method. It is just that you put on the data, you get the product. You put on the data, you get the product, and it becomes easier for us, even for to deliver to our customers and other executives. The next part is the design, analysis, material, and the atomic scale. Okay. So as you know, nanotechnology, it acts at a very atomic scale precision level. It has very high accuracy, high precision, yet it has some drawbacks. We'll discuss it in the later part. As of now, all these things are clear to everyone. Any questions from the panel? Now we are going to discuss about the three main pillars of nanotechnological advancement or also nanofabrication. What are the three applications we are going to discuss here? How artificial intelligence, what are the three main core applications of artificial intelligence that aids to nanotechnology? The first one we have is the graphical neural network, that is the GNN. Graphical neural networks. Okay. So what happens is, earlier, to suppose I have a customer, he wants some material from me at some strength, some concentration, some scale, some size. Everyone has different desired properties. So that is high. That is why to get the optimum amount of chemicals or materials, there is a lot of confusion regarding all this. So just for all these things, artificial intelligence and graphical neural network, it is itself an artificial intelligence tool which removes this confusion and and makes us easier to extract the end product. The second is a closed loop labs. Okay. Okay. The reinforcement learning, other technologies are now advised by researchers. Now advised by researchers so as to remove the real-time application. Maintain real-time application parameters. Maintain the real-time application parameters. Closed neural networks. Closed loop labs are preferred. What do they do? Suppose I am doing something. I am doing an experiment. Even my months, weeks, and years of hard work will get wasted only in slight change in the reaction parameters. So what do closed loop labs do? They just maintain the reaction parameters. That is the temperature.
Little bit louder.
Sorry.
Little bit louder.
They just maintain the concentration, temperature, volume, all these ratios to optimum levels so that we get the desired product without any loss. That is the main purpose of closed loop labs. Next slide, please. CNN characterization, convolutional neural network characterization. Okay. So what we used to do is, we know that cell. Then we have the transmission electron microscope. These capture very high resolution images. So this earlier what researchers used to do is they used to sit, they used to gaze at the micrographs for long times. They used to look after the crystal defects, which was not very accurate. Either it was very timely. So what does CNN characterization has? It is a very highly precise, accurate instrument for seeing the crystal defect, to see the material deformities, and it is spotting minute corpuscular particles so as to remove these barriers. Now we are entering into the application parts of artificial intelligence and its convergence with nanotechnology. The first is the AI-powered nanomaterials. It is very common nowadays in medical industry as well. AI-powered nanomaterials. Elimination of the systemic side effects. Now the questions may come, what are systemic side effects? Systemic side effects are nothing but there is a body fluid, systemic body fluid in our body. Okay. So how when these nanomaterials enter into our body, these body fluids come in contact with the receptors that are present in the nanorobots. These fluids come in contact with the nanorobot. These fluids after coming in contact with the nanorobots, they detect whether something is wrong in our body or not. That's how these nanorobots work. Biochemical markers to create cancer cells. Our cancer cells have some lacks apoptosis. Apoptosis means self-generating property. After our cell dies after a particular amount of time. In case of these cancer cells, if they do not die, they lack apoptosis because they are lacking an enzyme known as telomerase. So that is the reason why to detect cancer cells, we also use nanorobotics to detect what the cancer is doing, how far it has come, and what is the extent of the cancer cell. Also, a micro-targeted medication retina. What it is meant to say is, you can say there is a image saying that nanobot is entering into a cell and it is entering the targeted drug delivery onto that specific cell only. That is a targeted drug delivery cell. It will only interact, only counter with the defected cell that is present in the body part. Is it clear now?
Yeah.
Any doubts?
Louder, a bit louder.
Next, the second part of our application is the early diagnostic biosensors. First topic also the ultrasensitive detection. Suppose something is wrong in our body, until observable symptoms are visible to our eyes or observable symptoms can be detected, sometimes the situations even become fatal for us. So in this case, ultrasensitive detection, such as very low amount of pathogens or if present in our body, these can detect that, which makes very easy for us and also for the medical professionals to treat us and also to us get treated. Also, there is one very common thing in us, that is pacemakers. These are almost used by 1 in a 10 men in a family. So that is how the problem is that pacemakers cannot be regulated once they are entered into the body. So now what has happened? Artificial intelligence had made it so much seamless that we can just maintain it on a phone or devices to check whether the battery percentage, how far it is going to last, what is the condition inside. It is very definitely in this image, the person is using phone and can see what this is placed and how it is being located. Coming to the third point of our application part, this is the smart materials and sustainability. Here we can see aerospace components. Carbon nanotubes, that is often called as CNT, these are used in aerospace components because they are very lightweight than aluminum and other metals, which makes the aircraft very lightweight and fuel effective, and it is very much fuel effective. The second part you can see photovoltaic, piezoelectric, and thermoelectric. Now there must be confusion on what is photoelectric, what is piezoelectric, and what is thermoelectric. Photoelectric is nothing but it converts the light energy from the sun and converts into chemical energy. Coming to the point piezoelectric, it mainly acts on deformities. If any deformities exist, it will come back to its normal size after gaining some amount of energy. The third point is thermoelectric. The word itself is thermo, that is there is a chain exchange of energy between them. Solar energy. This material, this energy what we do, they act in combination with the AI. Since the sun is not at fixed rotation all the time. It changes its rays. So that is why what does AI enable us to do is it just keeps the solar panel move according to the sun's radiation and absorb the maximum amount of light it can obtain. The third part is the environmental remediation. We know that a lot of chemical spills and wastes are dumped all over the oceans and everywhere. So that is why drones in corporations with artificial intelligence can monitor them, rectify this issue, and can resolve this issue to a great extent. Coming to this part of the presentation, I have just put on this market and market improvement. What part of market is what percentage of market consumption is there for artificial intelligence and nanotechnology. Here you can see the biomedical and life sciences contribute to almost about 43.5% in the total market sector. The advanced nanomaterials contributes to about 25.8% in the total market sector. This nanoelectronics and semiconductors almost 15%. The semiconductor itself is going to industry business, we can all see. Energy storage and conservation 8.6%, aerospace and chemical applications 4.1%. Now, after discussing all of these things, we must see that there are certain challenges also incorporated into it. The first comes a limited high quality data. We all know that nanomaterials, to prepare nanomaterials, to go for the nanomaterials, there is a lot of data has to be required. But the issue is there is not that much data related to nanoscience, not much accurate data related to nanoscience, which I think is a very major drawback in current generation. Safety and ethical concerns. Combining nanomaterials with artificial intelligence is beneficial, yet it can have some ethical concerns. Since it is artificial intelligence have made nanotechnology easier, it has also some drawbacks. Ethical concerns such as hacking and all these things are very common these days, and this can also diminish the use of nanomaterials. A lack of standardization. Every industry, every company, everyone uses defined chemicals, defined machines, defined equipments for the final product. But what happens is a lack of standardization. There is no definite fixed amount of product that you go by this thing, you do this, there is nothing like this. Everyone is doing arbitrary motion and obtaining the final data, which is our major drawback in today's time. The next one is the convergence and future road. The first is the in silico design, which is algorithm replaces manual lab trials. That is we discussed earlier also that manual lab trials and hit and trial method are replaced by artificial intelligence these days, making it convenient to enter into a nanotechnological field. The next is the self-driving lips, robotic clearance and automated synthesis. Okay. Nowadays you can also see that in schools, colleges, everywhere, robotic clearance are preferred everywhere. What does this do? This makes it easier to monitor things even at every level. The The phase 3 the targeted therapies. We have already discussed the applications part before. The targeted drug delivery in the cancer cells and anywhere biomineral sensors to detect the errors going inside the body. All these are a part of the future convergence roadmap. Yes, advancement is still there, but still more technological advancements are required in the process. Part 4 is the molecular computing, such as to, I can say, for example, to identify gene defect. Our genes are specific codons such as A, G, C, C. These are the specific repetitions. The molecular compounding helps to identify this gene defect, which can treat abnormalities in a newborn baby to prevent it from some syndromes like Turner syndrome, Wilkinson syndrome, Klinefelter syndrome, all these things. Next slide. Just reaching to the conclusion, I have just to conclude that artificial intelligence and its convergence in nanomaterial technology has a very broad potential and has the capacity to resolve issues in every possible sector. Thank you.
So you really did very good. Last moment, his things was really, I never thought that it would come to that stage, and the way he presented things is good. That's a very